Compact decoupled antenna pairs for 5G. Applications. Abstract. In this letter, a compact self-decoupled antenna structure is proposed for the 5G multiple input multiple output MIMO operation in 5G tablets. The antenna structure consists of two adjacent antenna elements, which are placed very close to each other, which is placed at a distance of 1.2 mm and located on the same side of the system ground plane. A compact self-decoupled antenna pair can be obtained by sharing one common ground. The MIMO antenna system is optimized to operate in the 3.5 GHz, 3.4–3.6 GHz band with isolation better than 3.5 dB. An antenna prototype is fabricated, and good results for simulation and measurement is obtained. The gain obtained is 3.3 dB. An antenna is fabricated and good results for simulation are obtained. Index terms 5G, tablet, multi-input multi-output, self-decoupled, compact antenna. Introduction. In the upcoming world, 5th generation electronic devices will play a major role, and it will have advantages such as higher transmission rate, high reliability, low latency when compared to 4G 3.10. So the upcoming generation will mostly rely on 5G communication electronic devices. To meet the requirement of 5G, MIMO, multiple input multiple output, antennas operating in sub-6 GHz band FR1 range, 410 MHz 7.125 GHz, used in 5G electronic devices 1. 3. To meet high isolation in 5G electronic devices like 5G tablets becomes challenge in before years 4. In past, many methods were proposed using neutralization line to improve isolation 2. 5. To overcome this problem, MIMO antenna structure is used. In this letter, we have proposed 4 decoupled antennas shaped ring common ground to meet better isolation 6. 8. 4 antennas split into 2 antenna pairs very close to each other. The antenna pairs shared a common ground and the antenna pairs are isolated by I-shape isolating element 9. The performance of our proposed antenna is verified using simulation in HFSS, High Frequency Structure Simulator, and by fabrication. 2. Compact decoupled antenna. The dimensions of the compact decoupled antenna pairs are illustrated in the figure 1.1. The dimension of the substrate is 150 mm x 75 mm x 0.8 mm and the dimension of the ground plane is 150 mm x 73 mm x 0.8 mm. 2 antenna frames are placed on the left and the right side of the substrate. On each of the antenna frame, antenna pairs are printed separately. The length of the antenna frame is 150 mm and the width is 0.8 mm and the height is 6.9 mm. The system substrate and the Divya. C. Karthini. B. Department of Electronics and Communication Engineering. Mepkoshlank Engineering College. Virudhunagar, Sivakasi. Antenna frames are based on the FR4 with relative permittivity, ER. 4.4 and dielectric loss tangent 0.02. Each antenna pair consists of U-shaped radiating element, U-shaped feeding element and I-shaped isolating element. U-shaped feeding element is used to obtain better gain and isolation loss. The length of the isolating element is 6.9 mm and the width is 0.8 mm. The arrangement of the antenna pairs is done in such a way that below the U-shaped radiating element, U-shaped feeding element is placed in order to get good return loss. For better isolation, an I-shaped isolating element is placed in between each antenna so that we can achieve good isolation loss. Microstrip feed is used to obtain better return loss. Here we use 4 microstrip feeds. Each microstrip feed is fed with each feeding element directly. Length of each microstrip feed is 12.2 mm. 2 feeds are placed on the either side. 4 microstrip feeds are fixed on the substrate. Each antenna pairs share a common ground. The horizontal coupling gap between U-shaped radiating element and U-shaped isolating element is 0.2 mm. The gap between each radiating element is 1.2 mm. Each antenna pairs are located in the middle of the antenna frame. All the Antennas are fed with 50 SMA, sub-miniature version A. Connectors via hole from the back side of the system substrate. 0.4 SMA connectors are used to connect the 4 microstrip feed with the ground. Is the wavelength. F is the frequency. Width of the patch is given by. Where is the dielectric constant of the substrate. Length of the patch is calculated by. Where lef is the effective length. Effective length is given by. Where RF is the effective dielectric constant, the normalized extension length is given by. Where H is the thickness of the substrate and W is the width of the substrate. Effective dielectric constant is given by. Where H and W are the thickness and width of the substrate respectively. Length of the substrate is given by. Width of the substrate is given by. Height of the substrate is given by. Guided wavelength is given by. The feed length is given by. The main purpose of the antenna is to get better isolation loss. The proposed antenna structure antenna has a better isolation loss of about 32 dB and 39.93 dB. The isolation is obtained by the common grounding of the antenna pairs. The obtained result is shown in the figure 1.3 and fig 1.4. The radiation pattern obtained for the proposed antenna structure is omnidirectional and it is given in the fig 1.5, and a 3D plot is also obtained and it is shown in the fig 1.6, and the efficiency of the proposed antenna structure is 71% and a good arrangement for simulation, and the measure is observed. For obtained results, an antenna prototype of the proposed 4-antenna MIMO system was measured and fabricated. With the operating frequency of 3.5 GHz, the obtained return loss is about -35.8 dB. The simulated result obtained is shown in the fig 1.2. Fig 1.3 isolation loss. Fig 1.4. S parameter, S14. The results obtained confirm that the performance of the MIMO antenna structure is more than enough for 5G applications. Conclusion. A compact decoupled antenna pairs for 5G applications like 5G tablet was proposed. By having two antenna pairs and the antenna pairs share a common grounding, good isolation of about 39 dB is achieved even there are very close to each other. The proposed antenna structure has good isolation and high return loss, which is most suitable for the 5G applications. The efficiency obtained is also greater than 70%. And it is more useful for 5G applications. Acknowledgement. The authors thank the reviewers for valuable comments and the feedback.